This video is going to cover section 9.3, which is about solving absolute value equations and inequalities. So our two objectives for this are to learn to solve inequalities, or to solve equations with absolute value. And second is to learn to solve inequalities with absolute value. So let's just remind ourselves what absolute value means. The absolute value of x, which we write like this with the absolute value signs, is defined this way. It's x if x is positive or 0, and it's the opposite of x if x is less than 0. Now, what's the opposite of x if x is less than 0? Well, if x is less than 0, then x is a negative number, and its opposite is a positive number. So this definition tells you two things. Absolute value is always positive or 0. And if you think about it, absolute value is really the distance that you are away from 0 on the number line. So let's just find the solution set for some very simple inequalities. And then we'll kind of put that together into more of a generalized concept for solving equations with absolute value. If the absolute value of x is 6, what values can x take? Well, x could be 6, or x could be negative 6. So the solution set is 6, negative 6. Here, the only thing that has an absolute value of 0 is 0. So the solution set to the absolute value of x equals 0 is simply 0. And here, remember, absolute value is always positive. So if you're being asked what value has an absolute value that's negative, there is no solution. And we can write that as the null set, which could be written either of those ways. That means the empty set. The set of the solutions is empty because there's nothing in it, because there's nothing that solves that equation. Okay, so here's the absolute value principle for equations that you should already pretty much have swimming around in your mind. We're just going to put it down formally now. The solutions, and this is for a positive number p, remember that, a positive number p, that's important, and an algebraic expression x. So it doesn't even need to be just a simple variable x. It's an algebraic expression this will work for. The solutions of the absolute value of x equals p are the numbers that make that algebraic expression x either the opposite of p or p itself. Secondly, the equation the absolute value of x equals 0 is equivalent to the equation x, algebraic expression x equals 0. And the equation the absolute value of x equals the opposite of p has no solution. Because if p is a positive number, its opposite is a negative number. An absolute value cannot be negative. So we'll do a couple examples where we're using absolute values. And what we have to do is we have to take that algebraic expression, so I'll start with this one, that algebraic expression that's in the absolute value sign, and we have to look at the two cases. The first one where it equals the opposite of the number on the other side, and the second one where it just equals that number on the other side. And then we'll go through and solve these like we would solve regular equations. So we get 2x equals negative 6, and we get x equals negative 3. Here we get 2x equals 4, and x equals 2. So the solution set is negative 3, 2. The second one I want to do over here, we're going to again split it up into 3 minus 4x equals 10, and 3 minus 4x equals negative 10. So we'll get negative 4x equals, if you subtract 3, you get negative 7. X is going to equal 7 over 4. And over here you'll get negative 4x equals negative 13. X equals 13 over 4. So our solution set is 7 over 4 and 13 over 4. Now here we're given a function, f of x, which has an absolute value in it. And we want to find all the x's for which f of x equals 11. So what I'm going to do is I'm going to put that 11 in for the f of x. And I'm going to rewrite all this. And now I want to get the absolute value of the algebraic expression all by itself on one side. And then I can solve it just like I solved the 2 on the last slide. So I'm going to add 4 to both sides, and I get 15 equals 3 times the absolute value of x plus 5. And I'll divide both sides by 3, and I'll get 5 equals the absolute value of x plus 5. Which means now I can say that x plus 5 equals negative 5, or x plus 5 equals 5. So here x would equal negative 10, and here x would equal 0. So the solution set is negative 10, 0. In other words, the two x values for which this function value is 11 are negative 10 and 0. Now, sometimes an equation can have an absolute value expression on each side. So that means that they have to be the same distance from 0. Remember we talked about absolute value measuring distance from 0. They're the same distance from 0. Either they're equal, they're exactly the same number, or they're opposites. So to solve this, you would do 3x minus 5 equals 8 plus 4x, or 3x minus 5 equals the opposite of 8 plus 4x. Solve both and you'll get the x values that are in the solution set. Now I just want to note that I wrote this with the second expression as the opposite. it's the exact same thing if I had written it like this. And that's just a matter of simple arithmetic. If I multiplied this green equation through by -1 on both sides, I would not be changing the value of the equation in any way, but I would get this red equation. So either one can be, you can take the opposite of. And sometimes it's going to be easier to do the opposite of one than the other, so that's the one that you should use. So we have a method for solving equations with absolute values, and we can adapt that to solving inequalities with absolute values. Now, it is true that this is going to arise regularly in more advanced courses, but this is a good time to learn how to do it because it fits perfectly within the context of what we're doing, solving inequalities and solving absolute value equations. So let's look at something like solve the absolute value of x is less than 3, then graph. Well, we know we want all the numbers whose distance from 0 is less than 3. So basically we have the solution set, the set of all x, and I'm sorry that this breaks from line to line, but it does. So the set of all x such that -3 is less than x is less than 3. In interval notation it looks like this. And on a graph it's going to look like this. We're going to have -3, -2, -1, 0, 1, 2, 3. Pretend all those are equidistant from each other. And you will have open circle and open circle and a line between, or you could also use parenthesis, parenthesis with a line between. So the last thing we're going to try to put all this together and solve this inequality and then graph it. So remember that we have 3x plus 7. Its distance, its absolute value is less than 8. Which means this expression itself is less than 8, but greater than -8. It's between the two, right? That expression's distance from 0 on the number line is less than 8, so that expression's value is between -8 and 8. So I think this is kind of fun. You can do things to all three sides at once. So you're gonna subtract 7 from everything. And what do you get? -15 is less than 3x is less than 1. And then divide everything by 3. And you get -5 is less than x is less than 1/3. So it's the set of all x such that this is true, or it's the open interval -5, 1/3, or on a number line, we have 0 about here, -5 is about here, and 1/3 is about here. I'll do this in red so you can see open circle, and line, or parenthesis, parenthesis, and line.